binomial expansions. CORE2. Going to expand a plus b all squared. It's called binomial because it's got two terms, a and b. Now, a can stand for any number, or indirectly it can stand for any other letter that stands for a number, and likewise b. Let's see what we get when we expand this. We'll top and tail it. So a times a is a squared. A times plus b plus ab. Now, tails. Plus b times a is plus ab. We put them in order, remember? And plus b times plus b is plus b squared. And if we simplify it, we get a squared plus 2ab plus b squared. In other words, we get the first term squared, the last term squared, and in the middle we get double the product of the two terms. Now, I said a and b could stand for anything. So we can use this, for instance, say I were to expand x plus 1 all squared. In this case, a is x and b is plus 1. So I can quickly write down, replacing a with x and b with 1, that the expansion is x squared. At the end, it's plus b squared, so it's plus 1 all squared, plus 1. And in the middle, it's twice the product of the two. X times 1 is x, double that, plus 2x. All right, and you've come across that expansion before. But let's look at another example of its use. Let's say we had to expand this here. Let me just put it on pause for a moment. Right, now, let's have a look. So in this instance, a is 3x, and b is plus 5. So, here is our expansion. It's the first term squared. 3x times 3x is 9x squared. It's the last term squared. And then, it's 2 times the product of the two. AB is the product of the two. 3x times 5 is 15x. Double it, 30x. And so on. In fact, here's another interesting use of it. What about 107 squared? Well, here's how we could use it. That's the same as 100 plus 7 all squared. So A, in this case, is 100, and B is 7. So when I expand it, I would get 100 squared, which is 10,000. At the end, I get plus 49. And then I get twice the product. 100 times 7 is 700, doubled 1400. So the answer is, add all those together, and we get 11,449. A bit quicker, you'll agree, than doing long multiplication. Right, okay, we'll just stop the video there. That's the introduction to it. Now we'll look at expansions other than squaring. Anyway, thank you. I hope you found it enjoyable.